Yes.
Am I audible enough, or do I need to use this thing? We good? If nothing works, I'll scream. Okay. So yeah. So I think enough has been said about the setup, right? So I'm not going to waste time there. My name is Rishabh, based out of India. I am part of VCF Networking, aka NSX Product Management team, right? Today we're just gonna lean a little bit harder into what NSX is in VCF 9.1, what it's supposed to do for you, what you think it should do for you, and absolutely the bare guts of what you want it to do for you. So if there's gaping holes in there, don't be afraid, just tell me. Okay, I'm a big boy, I can take it. And the idea is to engage, right? It's been mentioned twice, so I'm not gonna harp on it. But the idea is I need to take back stuff that works, stuff that should work. And that's gonna make it into the roadmap. Okay, so with that, let's just get into it. So I think Saj put out a very, very crisp agenda. What I'm going to talk about is some amount of evolution, how you become VCF. So just imagine, like, we've all run labs, we've all run deployments, day 0 to day N. And once you have that mindset, I can try and put in NSX pieces across those days. So that should give a sort of a real world application kind of tone to this conversation, right? So we talk about first, how do you become VCF 9.1 with NSX in it? Then what can you do with it? How does it help you with operational side of things? How does it help you be secure? And I'm not here to talk about the security offerings, but how you apply those. How do you be secure, continuous compliance, that kind of stuff, right? So you're going to hear about, and then of course, when you run a stack, you absolutely have to ensure that the pieces that manage that stack behave cohesively. So cert management is one thing, but you plug it with security and it becomes another thing. So, each of these products cannot keep doing their own thing. They have to behave in a certain way. So that's common services. And finally, we've all heard the word VPC, VNA over and over again. I will tell you what exactly it is, where it fits, and that it's not just another acronym to a very long list. Okay, so it works. Okay, so again, you must have seen this, but because I'm going to be connecting dots here, right? So let's just think of a stack over here, a few pieces over here, and again, I'll just keep on touching on certain terms, right? So for example, load balancing, advanced security, you have different compute, storage, network, core infra. You have all of this in a very nice shiny diagram, but what does it mean? Like, so in fact, let me throw it back to you, right? What's the worst definition of VCF that you can throw at me?
Commander be sure.
Product bundle.
Okay. Anything else? It's okay. So simply put, you've got traditional workloads, you've got leading edge, you've got bleeding edge, and now everybody wants a container. Everybody already has a container, wants to scale up, scale down. But if you just do bundle upon bundles, it's not going to do the job, because it's a pipe dream that I will have a data center with just a homogeneous stack in it. It's a heterogeneous world. You will have fabric, you will have multiple components, you will have integrations, and on top of all that will be your business use cases. So somehow those things have to work cohesively with one another and give you the business outcome that you're looking for, which is essentially what the slide is saying in much more intelligent terms. So you've got Kubernetes, traditional VMs, AI/ML, you've got core infra, nothing works without that. You've got different kind of services on top, so application services, automation, edge orchestration, and that's all exposed via VCF Advanced Services, right? That's what this stack is. It's taking a whole lot of things that you need, putting it into a cohesive framework where everything behaves in a consistent manner, and then it delivers the business outcome you're looking for. Now, where does NSX fit into all of this? Private or public, service consumption without networking is not going to happen. Things need to talk to each other. That's where NSX gets in, right? So all that plumbing, all that piping, that's a little basic, right? Moving on. So let's talk about, okay, you've told me VCF, you've told me NSX, we've heard a lot about NSX, But one thing that a lot of a lot of customers, internal partners, everybody right now, a phase that you're going through is how do I become VCF? So you've heard certain terms, right? Brownfield ingestion, converge, import, workload domain, management domain, depending on whether you're VCF today or you're running NSX and vSphere, right? How do I become VCF? In fact, let's take a step back. Before I become VCF, how do I decide how to become VCF? What's my decision matrix? What do we do, right? Let's start there. Okay, so these are all terms. It's really quite simple. You're running NSX today. You want to become VCF 9.1, right? That's what you want to become. You want to become NSX and VCF 9.1. So you basically take your existing NSX environments, vSphere environments, your data path, you turn them into VCF, and then you land in 9.1. That's what it really is, right? But under the hood, how can we make it easier? Because there's a ton of detail involved. So we have to preempt things, right? We have to do a lot of that plumbing ourselves, so you don't have to do it repeatedly over and over again. That's what there is, right? So for example, native fleet integration, right? So what it really means is we will deploy the mandatory components that can then manage all of these pieces together in a stack as part of that process. What are those components? Operations, mandatory services, SDDC manager, right? Synchronization API. So when you're dealing with NSX, vCenter, this is about NSX, but I'm trying to connect the full picture because what's NSX without the data path, right? It's one piece, but you have to look at the full picture. You've got multiple inventories. You've got VC inventory, you've got NSX inventory, you've got SDDC manager inventory. Unless the state of all these inventories are in sync at the same time, it's not going to work. So that's what it says, right? Remote sync API reconciles inventory metadata. So there's a lot of stuff that we preempt. We make sure that those inventories are in the right state. So for example, do I have MP objects? That's not going to work with VCF, right? I'm sure folks are aware of MP objects back in NSX, MP to policy conversion. You now use policy APIs, the policy engine. So for example, if my inventory has MP objects, I would not allow you to become VCF, first convert those. Similarly, VLCM or WAM clusters, which you know as image lifecycle management versus baselines, right? So as part of VCF, now I want to keep one lifecycle engine, which is VLCM, which is a cluster-based contract, right? Because you want to manage compliance at a cluster level. You go host by host, that becomes very difficult to manage to scale when you scale, right? So now all of these things have to be taken care of beforehand. So instead of letting you figure it out, we've done the plumbing under the hood. There's a cohesive framework that checks the state of your system and then tells you exactly what you need to tweak, what you need to drop, what you need to transform before you can begin that transition. And all of that happens over here, between the SDDC API, synchronization API, and pre-check and cleanup rules. So anything that we find, which we know can be a blocker, will be flagged up ahead of time before you even begin. Fail first, right? So that's what it is. So that's brownfield, import, and fleet onboarding. While these are many different terms, the experience is one atomic step. So you get a consistent set of results, a consistent set of remediation steps that you need to take, and then one single atomic step that takes you from an NSX vSphere combination to a VCF environment. Okay. Now, okay, I've done all this. I've done NSX, I've done vSphere. So what's new? Like, what am I getting over here, right? How do I make that decision? What are my guardrails? How does VCF stop me? How does NSX stop me from making mistakes before I even begin, right? Okay, so first things first, question number one, do you want traffic separation between your management network and your workload network? That's what you need to answer for yourself first. Okay, do I want to run consolidated? What are my latency requirements? Do I have disparate data centers? What is my fabric like? That's your know-how of your own data center. Then we lay this framework on top of it. And just imagine like, two camera lenses aligning. The final focal picture that you get is your decision matrix. So for example, I have host profiles. Okay, sure, use host profiles. But now when you're connected with NSX, you're looking at per host configuration. So you want to manage it at cluster level. So here comes VCP, vSphere config profiles. Again, completely housed and owned, fathered by VLCM. So it's all one framework. Similarly, MP objects. Policy transition was done keeping in mind because we have to go the VLCM way. It works with that. So this is how you get to this part. Like, what's my first step? So everybody has a management plane, right? NSX has a management plane, vSphere has a management plane, VCF has to have a management plane. What do you want that management plane to look like? We can't tell you. So one of the analogies that I often use is, imagine Lego blocks. We'll all use the same blocks, but Nathan being Nathan will create, I don't know, the Falcon Star out of it. I'll make a simple house. So that's what it is. These NSX at its very fundamental is easy provisioning and consumption of networking services in a private cloud. How easy and how complex, or how whatever, that's where you come in. You got to define that for yourself. We'll make it happen, but you have to first tell us what do you want to happen. A DMZ1, DMZ2, logical isolation, separation, stretched networks. We will make it happen, but you first need to tell us what do you want, right? So that's your management first order. So that's what I say, right? Orchestrated update sequence begin with VCF operations. So operations is like the first step in any process. You do import convert, it will deploy an SDDC manager, which is essentially running under VCF operations console. VCF operations is like the one-stop shop for, I said, right, day 0 to day n. For day to day n, VCF ops is your one-stop shop. Everything happens there. That goes on first. The licensing server lives inside VCF ops. So entitlements are taken care of. We'll talk about reduced downtime vCenter a little later. Now, network requirements, right? So we're changing some stuff which impacts everything. So how many people have sort of almost lost their will to live when it comes to SSO, secret management, identity management, IPAM? Okay, so that's where VIDM is out, VIDB is out. A single identity broker for the entire stack. Okay, so again, before somebody raises their hands and says, I have an LDAP integration, I have an AD integration with 500 local accounts that I have to manage manually. That's coming, that's going to happen. All managed via VIDB, a single OIDC. Okay, so no more password rotation, no more different management, a centralized fleet policy, and you'll keep hearing the word fleet. So today I have an NSX and VC service account, right? It gets created automatically, you don't ever see it, right? That's how NSX and vCenter connect for their life cycles. We rotate it automatically, but at the same time, we call them local accounts, but a lot of people would call them service accounts, where your applications actually create local accounts on the application that you then use for other communication, right? All of that disparate stuff is being cleaned up, being given a right standardized API contract and pushed into VIDB. So all your SSO, OS, OIDC, third party, Entra, all of those integrations in one place. Again, completely managed from VCF operations. Then you got IP blocks, VLANs. We love VLAN. We will always love VLAN. Okay, keep loving it. Nobody's asking you not to, right? So VLAN backed VPCs. Okay, add one more. For you, it might mean adding a VLAN segment. For your end users, it will mean possibly about 10,000 plus unique IPs. Consumption, a stupid button for quick, easy consumption of networking and security in a logically isolated construct that you can actually do from vCenter. So no more TNP creation, transport node profile creation, figuring out what my lag is, my teaming policies are. Once that is set up, no more ticketing. Just go in there and you can actually get, all you have to do is like give it like the IP block, the subnets. But after that, it's click, click, click. I have a VPC, a ready to use cluster with core networking. So networking, compute, storage, ready. No more ticketing at all. Okay. Moving on. So a couple of things that do make this happen. How many people over here have actually managed an NSX upgrade? I won't say 4.2, 4.2 is a lot better. Let's go a couple of versions before that. 4.1, 4.0, 3.2. How many people have done an NSX upgrade over there? Kums, how was it?
I mean, we do use the edge node, so it's harder for us a bit. But yeah, rest of the things, the time taken is higher, but it gets done. The maintenance mode on the ESX is fine. We don't have any problem.
Okay, so here's how it is. I'm completely repeating myself saying stack, stack, stack. So if there's a stack, there is one data path, ESXi. There's a hypervisor on top of it. It has a golden state image that is VLCM, which is, load up everything in this desired state image, point it at a cluster and just tell it like, what's in line, what's not in line, right? Then why do I need two different lifecycle engines for my core infra on the same hypervisor? Why do I have to rev an ESX VIP and then I have to rev an NSX VIP separately? While you say that, okay, it's all VLCM, it doesn't fit. So basically, starting 9.0, we've just taken the NSX LCP bundles for folks who love console, like, consoling into boxes. We've taken the NSX.LCP bundles and we've pushed it in the ESXi base image itself. Okay, so what that simply means is upgrade ESX, NSX VIPs get upgraded with it. But not always, because that will lock you in. 5 kinds of releases in VCF, right? Major, minor, maintenance, express patch, hot patch. For express patch and hot patch, ESX and NSX VIPs on hosts can be revved independently of each other. So it's like, oh, I have a CVE 9. I want to quickly patch up my NSX, on all my hosts. But crap, I need to upgrade my ESX also? No, you don't. Just patch those bits. Okay, so while these have been clubbed, flexibility has still been maintained, and we're right now working to extend that flexibility to maintenance releases also, the third digit. So we're working on that right now, but express patch and hot patches are like completely, NSX and ESX are independent of each other. Just keep revving them, no problem. There's interop already built into the code. So if you try and do something which goes beyond the limits, it'll stop you there itself. It's, okay, let me say it. So this is how it works. Let's just say you have VCF 9.1 running. NSX, ESX, everything installed, running, all good. Patch comes out. Go into VCF ops, go into lifecycle, the tab, okay? Figure out the exact workload domain where that cluster is, where you want to patch. You see a button called plan patching. Hit that. All the GA patches that are applicable show up in a list. Different kinds. ESX only, NSX only, ESX plus NSX, maybe other components, because there are different cadences. We roll up patches. We also do hot patches, which are like for stuff which is immediately on fire. Pick the patch. There's a button called run pre-checks. The best part is all of this is within the VLCM framework, which is native to vCenter. So you are really not, it's not a hook into anything else. It's all core vSphere territory. Okay? That pre-check framework is integrated across NSX, ESX, vSAN, including EHP callbacks, which are runtime checks. Okay? You hit that button, it will tell you a very clear answer whether that cluster is safe to live patch or not. It will also tell you in some cases, depending on the condition that we detect, whether that particular condition can be remediated by yourself, or do you actually have to go do something else, talk to support. It's green, hit patch, no DRS, no vMotion, live patch. And when you have AI threats, continuous compliance, sensitive workloads, highly regulated industries, with government oversight, and you want to have, and sometimes you're led into a cycle of continuous patching, then that patching has to be live. You can't stop and go, stop and go, stop and go. It's not going to work. And when you talk about this base image integration, right? We are trying to find newer things to do over here. We're trying to push the envelope, but that is a little more leading edge right now, so I won't talk about it. But whatever I told you, other than that, is available as of today. So this is not the roadmap. This is not, oh, we're going to build it for you. We built it for you. It's out there. I mean, and I welcome anybody to spin up a lab and try and break it. We're looking for those gaps so we can fill those. Okay.
So this base image and VLCM, does it apply to VKS as well?
VKS supervisor cluster, but essentially, I mean, see, VLCM supervisor cluster it would, but as of today, I don't think VLCM extends to container. It's still traditional VM. But if you have a supervisor cluster in there, the piping's there. The interop and other things will be maintained. Okay, so orchestrated upgrade sequence. So back in the day, NSX was data plane first and then management plane. VMware was the reverse. VC first and then NSX. You put those together in a stack, they collide. Okay, so what you end up with is, I don't want to reboot. Unless I have to, I don't want to reboot. That takes a whole lot of time. Even with a fast reboot, I think some 30 to 40 minutes is maybe what we prescribe.
That's
Now,
being generous.
Come on.
Yeah.
Be nice. Nathan's here. Be nice. Okay, so take that into a production state with say 1,000 hosts across different clusters. Do the math. What is the number you're looking at? And what you get is, oh, I've been upgrading my prod environment 1 for 6 months. By the time I actually get that done, the next version is already out. So I'm constantly upgrading. Right? We've all seen that movie. Okay? I've acted in it. So how do I reduce the maintenance windows? How can I give you, I'm not saying reduce, it's like forced down your throat. How do we give you that option? Okay, step number 1, align the upgrade sequences. Okay, so now we flip the NSX sequence to match with vSphere. So now NSX manager gets upgraded first and then come the hosts and the edge nodes. So what it simply means is, if you look at this sequence over here, if you want, you can do your entire management plane upgrade in one single maintenance window because they're right next to each other. So, and you don't even have to do that, by the way. With time, as it gets confident, NSX Manager forever has been a rolling upgrade. We only upgrade one node at a time. Internally, we switch the virtual IP and reshard the host. So 2 nodes are always up and running, and we've tested it enough that it supports enterprise scale even with 2 nodes. So any incoming API calls, config changes, CRUD operations, they continue to work. And you don't have to worry about the virtual IP because it's a controlled failover, so it only switches once. So that slight sub-second disruption is only once. In 9.1, the whip switch time for folks with very sensitive workloads, we've actually driven it down to sub-second, like 1.5. So it's literally one blip, like it's hitless. Then comes in the vCenter RDU, reduced downtime upgrade. Anybody aware of that? You would be, of course. Okay, so reduced downtime upgrade, you create a blue-green scenario. Spin up other appliance, get the configuration over, upgrade the first one, cut over, right? Prescribed downtime 3 to 5 minutes. So now put these together, starting from NSX, flipped upgrade sequence, rolling upgrade, vCenter RDU, put those together. This is just for depiction purposes, you don't actually need a maintenance window. And VC RDU, we've built it in the back end, right? VC RDU has 2 phases. Once the prep phase, we are copying over everything, which is completely non-impacting to anything else. NSX Manager upgrade and vCenter RDU prep phase can be run in parallel. So there were some blockers over there. We've removed that. So for you, it would look like your NSX manager is getting upgraded, and in the backend, your VC RDU prep phase is also going on. When you're ready, just cut over. And that interrupt that my NSX manager has gone to the next version, VC still on the older version, it's all tested, nothing will break. So don't worry about what node has moved to what version, mixed version, VC is gone ahead, NSX is behind, blah blah blah. It's all baked in. It's not going to break. So what you essentially get is your entire management plane for compute, storage, network in one go, and if you want, no maintenance window at all. Then comes on the next stuff. Combined WIPs. Upgrade ESX, NSX gets upgraded with it. Okay. One last thing for folks who are Edge lovers. Edge had a problem of sometimes needing an extra reboot because the VMX driver on it would not be the latest. Because Edge, it's hard coded into Edge to pick the latest hardware from ESX when it boots up. So just imagine if this was flipped. Edges were first and then were hosts. So edges would go to the next version first and then would ESX. So if we had pushed, the new image had a newer VMX driver, you would actually have to manually reboot the edge one more time to get the latest driver. So what happens is now hosts get upgraded first. So they come up with the latest hardware list. When edges get upgraded and they boot, they automatically pick up the latest one. So long story short, one reboot less overall and no edge reboots. And by the way, it's all run from one single pane of glass, vSIF operations. Standardized API contract layer, if you want to automate it, Terraform, anything else you might have built, just point it to our exposed API surface, that's that. By the way, folks have been bitten in multiple places by NSX pre-checks. Okay, so now NSX data migration, which is the most critical step, is actually run completely in memory as a dry run, even before we realize the new intent of any changing API on the manager nodes. So it actually over here, just imagine another phase where we actually run all of those checks, like something as big as the data migration, where we're basically upgrading the schema in the Kofu repository. We basically do a dry run in the memory itself. So I mean that's about as safe as it can get. All the different pre-checks are also integrated into a single pre-check framework that gives you a very detailed report in different form factors. So it's all there. And we built it from a perspective that, okay, I am going to go upgrade my NSX. What does my typical journey look like? 6 months ahead of time, check it. Are there any hardware problems? Because those take the longest to solve, right? Maybe I need some new hardware. Closer to the upgrade, okay, let's start checking actually, something that you could call quote unquote runtime, like how things looking. Very close to the upgrade, you're like, okay, I have to communicate with all my application teams because I have to do change management in a large setup. I need to understand where the failovers are. I need to understand when things will be down. I need the exact runtime health before I hit upgrade, right? The pre-check framework, unified pre-check framework has been built with that in mind. So what we do is, let's just say NSX, vCenter and all of these have say 50-50 pre-checks. We figured out the pre-checks that can be run ahead of time without impacting anything else. Internally we call that a perspective. They get run first. Then come in the EHP callbacks and the other things which are a little close to runtime. They are in a separate section of their own. And internally, we've just baked it all in, which check needs to run when and which check needs to be repeated. It's completely abstracted from you. So before each host goes into a maintenance mode, you don't need any hooks. We will check the EHP. And by the way, back in the day, vSAN was a little out there. It was always like NSX vSphere, but vSAN out there. vSAN fault tolerance, which is like mostly it's FTT1, right? All of those checks have also been integrated into the same script, same framework, all native VLCM. So anybody who's like, oh, my FT is 1, can I? Yes, you can. And if you can't, you will be stopped here. You won't even get to this stage. Similarly, net new BGP pre-checks for edges, which run before each edge node goes into maintenance mode. They run sequentially. The first check that fails, it will stop you there. So traffic, the idea is be a little conservative, but no traffic disruption. And some of the things that we're working on in future releases is separating the NSX manager and edge bundle. So now you can actually patch edges even more flexibly than you could, because edge will come with its own bundle .nub. So if I just wanted to patch edges and I don't want to touch my manager, because I have to go through a lot of compliance approvals, even though it does nothing, but I still have to. So that means a month for me. Just get the edge bundle, just patch the edges, don't touch the manager.
Just assume that it's always the next version. You're not jumping versions, so you can't ever go from .1 to .3, for example. What's the checks? The checking is the checking always from one version to the next only, or is it whatever version to whatever the target version is?
Version. So the internal VVS matrix, which is the source for SDDC manager ops. So basically what happens is, back in the day you might have seen a file somewhere called .tgz matrix. That was what NSX used to use, right? VMware had its own thing. SDDC manager had its own thing. We've taken all of those components and pushed it into this thing called VVS matrix. And now that is the source of interoperability and version checks for everything, and that is target version oriented. So once you declare, I'm going from X to X.1, it will basically backtrack and check every component that whether it works with X.1 or not.
We are using physical edges. If we do the edge upgrade separately, and then we start the NSX manager, will it automatically check that we're using the right version and skip over?
Because you've got bare metal, right? So yeah, that's a hard check, because the TN-MP channel, right? It doesn't matter if it's a VM or you might have actually seen it. It's called MP channel or MP CCP connection. Might have seen it in logs or somewhere. This is the local control plane that basically lives on every particular transport node. That is its heartbeat, that is its connection with the manager, right? The protobufs in there, you cannot have. So if this is my sequence, the system expects NSX manager to be either equivalent or ahead of the transport node. The protobuf don't work in reverse. So the moment you try and take an edge beyond NSX manager, like the next minor version, that will basically snap the connection. So we don't allow it. Long story short, you want to create an outage, so we just can't allow it. But you can still do it for patches though. Like once you separate the bundles, you could patch, and it's like a new express patch or a hot patch comes out, just rev the edge. And by the way, for folks who don't know, even if you have to patch NSX manager, not just upgrade, the express or a hot patch on an NSX manager is also rolling. So we only patch one node at a time. There is actually no downtime. So I've actually heard a lot of people, I don't want to touch my manager, patch my manager. It's not going to do anything. 2 nodes will anyways be up. So.
And if you had edge nodes, do they roll as well if they have low balanced high availability as well? Do they patch? So if you have bare metal edges, do they roll one, then patch, upgrade, then leave the next one, and then it rolls back?
Yeah.
Isn't there still a few minutes of downtime when the bit gets transitioned, or is that?
That's 9.0. 9.1 is sub-second. Are you talking about the search API, search downtime?
Yeah, in the manager APIs.
Against my best advice, somebody decided to put 17 minutes in our product documentation. I can assure you I had a very heart-to-heart with that person. Okay, won't happen again. It's sub-second. That's forward search API, that's a very corner case. So, and if you look at 910 Express Patch 1, just try it out in a lab. You'll see that it's sub-second. So it's. I mean, the only place, the most corner case which I don't think anybody would have is, let's say an NSX bit is being upgraded and a vMotion lands on that host at that exact same time. It's a 1 in a billion possibility, and even then you will have about 3 seconds, which we are trying to take down to sub-second. So it's a very corner case. Like, the moment we load the old and the new module and we try and update the port set configuration, a vMotion lands on that host at that exact millisecond. But that's a corner case, and we're trying to cover that as well. For all intents and purposes, sub-second.
So 910 EP1 and onwards.
910 onwards, but EP1, there was a slight little tweak we had to make, so we made that too. You don't look satisfied.
Processing all the
Now, if you have any questions, please feel free. Good?
There are lots of questions about this Python to the end.
Oh, okay, sure. No problem.
We haven't had problems with manager upgrades, but again, we prefer not to do any changes during that time either. At the same time, so
That's an abundance of caution. See, what I'm trying to say is you could.
yeah.
Whether or not you do choose to do it is your decision completely. I
The
mean,
risk factor still. Yeah.
there's a ton of VC customers who, no matter, they use RDU but still take an R as a maintenance window. That's just safety. That's your decision. Okay, this is, I think, has been mentioned a bunch of times. I've talked about this just like maybe 10 minutes ago. Live patch. Again, very quickly the highlights. Completely VLCM owned, natively integrated. No more NSX doing its own thing, vSphere doing its own thing. It's not vSphere and NSX. It's VCF. It's core infra. All under one framework. Operates as one single unit. And as soon as those checks say your cluster is live patchable, you're good to go. I mean, that's quite literally what it is, and we're trying to extend that to maintenance releases also. So, for example, if I have 9, 1, 2, 3, 4, right? For example, that's my release number. I want to keep because ESX upgrade is always the one that takes the longest because of strategic production estates. You could have hundreds of hosts, right? Clusters and then multiple hosts in each cluster. So I want to keep because networking is distributed. There are chances that the need for me to rev my networking will always be higher than ESX. So for example, I give you a new feature, EVPN. I want it quickly because I want direct fabric integration. I want to use that. But to get there, I have to upgrade all my ESX, which is 6 months for me, because I use maintenance mode. Just imagine this, right? If I loosen up the sequence for the third digit, what I could do is keep your ESX at 912, take your NSX to 913. And then we're also working on a feature which is called selective opt-in, where you could, via API, declare my minimum ESX version for this feature enablement is this, and this. And as your cluster, of course, it comes with caveats and you have to assume a little bit of risk over there. As your clusters get upgraded, the new feature will become available cluster by cluster. But right now, again, very large disclaimer, very loud and clear disclaimer, that's in nascent stages. We're trying to develop it. It'll take some time. But the whole idea is, can I get new networking features cluster by cluster without having to upgrade my entire ESX estate? That's the target we're working towards. So if we make that work, I think that will be a big one. I mean, when we make that work.
This
Yeah,
is
but
not patchable. Is there a downtime to data traffic on ESX?
Live patch?
Yeah, like-
No, nothing.
It's kind of like
We do it in memory.
But still, I mean, there are certain workloads which are they get impacted by vMotion, to be honest. So I'm just wondering if those kind of workloads will see any impact. We are currently doing everything under maintenance mode. and it takes longer time as usual.
That's the needle we're trying to move. So I would very much encourage you, spin up a sandbox, try it. I mean, we want you to be comfortable to a point where, like, hey, I'm confident enough to live patch my host. See, a continuous AI compliance is not possible unless we become more and more live in terms of patching, and you become more and more confident in using it. See, it's here, whether or not we like it.
So just to
It's not just our control, right? The main thing is that I have to align with some app team who can test it to that level where they are seeing no issues at all. And I can do that is non-prod, and I'm not sure if they will be taking that as a guarantee to do the same thing in production yet at this point in time. So it comes with a lots of ifs.
I get
the problem.
Hey, we'll cross them one by one. Don't worry. We have a conversation later this afternoon, right?
Okay.
We'll dissect that
So
situation.
live patching is becoming behind the scenes our fundamental focus because of the whole mythos and security patching, and it's going to continue happening. So what's live patchable now versus what will be live patchable in the future is only going to grow. So yeah.
Because if you're putting out express patches monthly, okay.
I mean weekly at the moment. We've had 4 express patches in the first month of. Sorry, I shouldn't say 4 express. We've had 2 express patches, but there's actually 4 variations of versions inside those express patches in the first month from security fixes, and that's probably going to continue for a little while. We reckon probably at least the next 6 months for all of the backlog of security patches and stuff that we've seen already as part of Mythos.
Oh, that's not stopping.
Yeah, I don't assume it will either. It's the bump.
Yeah,
I guess, of what I've
So
seen.
yeah, it's gonna peak and then it's gonna like in frequency. But the point I'm trying to make is if I'm putting out live patches, then they better be consumable as live as possible. It's only then there's going to be some sort of an equilibrium where maybe you're just 1 patch behind what we have, not 6 patches behind.
Is there a white paper that we can send to change management? And when they allow us to pay for changes? Like, obviously other customers also follow it. Like banks won't do it. Telcos are not going to do it. They still have to follow stringent change management process.
I think
So this is a process. This is going to be a process change based on the world, right? At the moment, we've had many conversations with banks and many other government organisations where the mentality has always been, when a patch comes out over the next month, we'll try and get that into the cycle of patching. The reality is that if you look at some of the Five Eyes discussions and everything around Frontier IO, you should have patches done within 48 hours, which means that's going to change the whole idea of process on how patching occurs, and that's where we're trying to align some of the things we're doing to become more consistent. And yes, it's going to be a change in mindset for some of those change management guys, but they need to come on board that journey around security and what's going to happen in the future in the security side of things, and that's important, really important. So yes, it's going to be a discussion, unfortunately, but yes, we need to. We're happy to have that conversation, by the way, as well. It's not just us. This will be everybody. The idea of how often patching is going to occur in environments has come to the point where we know of a discussion, and John mentioned it, where a banking network may be offline for an hour a morning between 2 a.m. and 3 a.m. because they have to do patching now on a regular daily basis or every 2 days, where it might be, because of that. So that's the kind of mindset that's suddenly starting to change a little bit just because of the world we're living in at the moment. So
I think, but again, I'm not committing to it, but I think some paper was being written. I'll check on it.
yeah.
It is externally shareable. I'll check on it, but don't hold me to it. I'll check.
No.
Hold into it. He's a PM.
Why do you think I'm saying that?
Like it's one step at a time. Like you just want to inform them that the new status quo, if we want standard changes, is that there's less complexity, less downtime, whatnot. And over time, when you keep talking to teams, they kind of get bored. Like, okay, it's same like last minute, right? And then it's like, okay, I guess you give all that a bit more quickly. So I mean, it is hard. Like I've done a lot of telco tool testing in the past, but at the same time, though, you just get that comfort level lower and lower, higher and higher and higher, and then over time, it just becomes BAU, right? But there is still maybe a minimum velocity, but yeah, it's just about comfort level.
Okay, so moving on, right? We're talking security, but security is not just perimeter, distributed. Security comes in a lot of shapes and forms, right? Certificates, man in the middle attacks, somebody using EKU on one client side but not on the server side, some using TLS, some using self-signed, some using MTLS. It's just like like a melting pot of different things. And then of course certificates is something that nobody enjoys, by the way, rotating, right? Like I haven't met a guy who gets up in the morning like, let's go rotate certs, right? I mean, it's something you don't look forward to, right? So okay, how do we take all that and how do we make that happen? Step number one, standardize. So in 9.1x, we're still figuring out what that X is. Hopefully 9.1.2. Okay. All certificates for NSX are going to be centralized into VCF ops. Still native NSX APIs, but managed from ops. So nobody has to change their automation, just point it to a new API service. No net new APIs. Okay. Step number two, no more self-signed certs. At the very least, VMC assigned. At the very least. We're trying to figure out how to make that transition also automatic. We don't have it yet. So for example, I'm coming from a previous version. I have a bunch of TN certs, hundreds, which are self-signed. You're asking me to not be self-signed. So who's making that transition? As of now, you. One release down the line, we'll automate it. So, ops itself is just going to convert it as part, just right after upgrade or as part of upgrade, we just convert it. Number three, NDC. Hosts hit NSX, VC root and machine SSL cert rotated at the same time and snapping the connection between NSX and VC. We had a couple of escalations like that. So there's NDC, non-disruptive certificate change between NSX and VC. So the communication stays alive even if VC changes its own root cert on the go. The signatures just get automatically updated. There is not even a blip. Okay. And lastly, Venafi, a couple of other vendors that we are extending our CS to. Right now, Ops supports Microsoft, VMCA. We are extending to Venafi and a couple of other players. That's the plan for 9.2. So that's to expand coverage. So for example, I have a subordinate CA. I want to use Venafi. I do not want to expose my CA. I want to have something in the middle. Okay, we'll support that. So there are three categories of certs that you're going to see in there. We're still building the mockups and stuff, so like I can't show you anything. But one is monitor only. That's certificates that you own, an external LV sitting outside of VCF, but you want visibility. Then there's core component certificates that are very much our own, but you use a CA for that. So visible and rotate, but you have to generate the CSR. I mean, we can't do it for you, like that's impossible. And third is inter-component communication, which will be completely abstracted. You don't have to worry. They will not be self-signed anymore. They'll be VMCA, but auto-rotated under the hood, no blips. So the idea is don't look forward to cert management. So we're trying to just get there, okay? Same story with secrets. One-stop shop, VIDB. Again, we're trying to extend it to the point where can I extend it to CLI RBAC through a centralized VIDB, because I know all of you love to SSH into boxes, right? No matter how many times we tell you not to, you will, and you will continue to, right? So that's a reality. Okay, so then yeah. So okay, how do I make that secure? So today what you have an NSX manager CLI, or you go directly into the box, right? How about I take that and I put it at the OIDC level? So now you have a centralized CLI RBAC and control authentication mechanism for all your boxes from VCF ops, is what we're trying to work towards right now. That's why you see the word roadmap over there. Okay, fleet password policy, rotating passwords wherever necessary, OAuth account, so inter-component communication, where there's going to be an authorization server within VCF ops. It's going to issue tokens for all the components, no more service accounts. And just take all your AD integration LDAP that you called service accounts, but for us there are local accounts. Put it all under one little framework, no password rotation whatsoever. So, unless you want to change it according to your company policy. But no more having to rotate those passwords on a 30-day period separately. So just take all of these different pieces, make them cohesive, make them consistent under one little framework, one console, one way to operate. So again, no more of that unwanted change management. I can't reach into that particular environment because turns out what? A cert has expired. A password's not meeting the complexity that you have now pushed, maybe through CyberArk. It's all gone. Consistent, one password policy, auto-rotated. We're not going to do it for you because we understand things like password and certs can cause disruption. So the strategy is that get to that version, nothing will change during your upgrade experience. You get to that version, and the next time, for example, you go rotate a password, the new policy will automatically apply. So there is, because we all have a strong aversion to the word quote unquote migration. So I just want to put it out there are no migrations. The next time you perform that action, the new stuff will automatically apply. So no, go to this script, run it for here, and we'll turn your certificates, none of that. The next time you rotate those things, the new changes will automatically apply. Okay. VPCs.
7 minutes.
Okay, so let me just go to okay. Let's talk about this, right? And the channel is always open, by the way. So if you want any more deep dive stuff like remotely, no problem. Okay, I'll start here and work backwards so we can cover it in 7 minutes. Okay. You know bare metal edges inside out, but very quickly, and I request you, give me some feedback on edge, not you. Anybody else? Is anybody hit memory scaling issues on edge? Has heard somebody hitting memory scaling issues on edge? Life cycling?
No, it's harder for us to determine whether the memory use is actual use or whether it is resource, reserve use or something like that.
Consumed
It's harder for us
use.
to determine. We are constantly 70-80%. We're not hitting any issues.
Mm-hmm.
So it's hard to say whether we are above capacity but just not hitting any problems, or whether the system just is having it reserved while it is actually 40 or 50% use and stuff.
So that's the monitoring side of things. But I would I be wrong if I sort of and again I'm not talking bare metal. I know that's like slightly unique, right? But that's all part of managing an edge, right? If you have an edge, you have to manage it. So tomorrow, if I say, oh, VPC is, it's the new holy grail, please consume it, but you're like, oh, I want to consume it, but I don't want to manage another edge. I don't want another gateway. I don't want to set up those VRFs, those siders and that kind of stuff. Can you give me something else? The answer is VNA. Okay, so edge does everything via TEP. You need to have a TEP to basically reach into it, to reach out of it, right? And then of course you have the VM form factor and all the mem and all the consumption that comes with it, the management. VNA basically is if you don't want to use an edge. So it's again a VM cluster, but the trick is that it uses the TEP of the underlying hypervisor, of the NSX. So it doesn't have an extra TEP. Now what that means is I can have a distributed gateway without having to do the complicated plumbing of T0 and T1, which means this. So this again is a transit gateway. What if I put another edge over here? If you saw another T0 out of here. So now you have this to manage, to be able to consume that VPC, but everything goes to that T0. You put that in a multi-layer architecture, and I think everybody can picture the connections going between different T0s and T1s for north, south, east, west, right? Versus I take that out. Of course, it's going to come with caveats, but what you're essentially getting is edgeless routing. The TEP, the hypervisor has a TEP. Why not use that? And stateful services. So it's easier consumption. It's another stupid button for VPC. Like I don't want an NSX tattoo before I go and start consuming VPC. Okay. Step 1 of tattoo removal. That's what it is. Okay. So that's where it says no edge step required. Stateful services on demand per VPC. And again, if you want to look at and one more thing, Just maybe yesterday or something, I heard this comment saying that we want the flexibility of networking that you are pitching, but we want to share resources between two teams that are sitting in the same room. That's what VPC span is. So you create a transit gateway which can actually span clusters. So what, again, this is like, I had to cram it into the same slide, but basically this thing over here is transit gateway. This is another transit gateway, and if you see, there are 3 clusters, and this transit gateway is sharing 2 clusters, this transit gateway is sharing 2 clusters. So the whole idea is, I want to use a VPC, but I don't want to care what underlying hypervisors are, what clusters are, where am I drawing that capacity from? You don't have to. This is what you need for a VPC. Step number 1, design it right. So VLAN, overlay, just get your IP blocks and everything right, right? Step number 2, whatever subnets you have, private or public, that you want to expose to your teams. That's your capacity management, like what my teams are going to need in the next 6, 12, 18 months. Set it all up. After that, for anybody into a VPC, has to do this. Go into vCenter, go to the networking tab, right click, add VPC, private subnet, public subnet, choose, give it the cluster, the ESX, which is, by the way, all pre-configured, so they don't have to pick something, right? Pick from the list, storage, create VPC, done. And that transit gateway, basically stretching across VPCs and clusters, means you can decide what intra VPC communication you want to keep and what inter VPC communication you want to keep. So you have a project, right? Let me just, this is the last step. I think this will tie it all together. This is the transit gateway. In this example, right? It's being shared across 2 VPCs, which by default means these 2 VPCs, the VMs in here can talk to the VMs in here. Okay? So this is the versatility of a transit gateway. I can use the transit gateway to actually connect to VPCs, or I can use the combination of transit gateway and VPC to isolate. So if I have different application teams which are T0, high throughput, sensitive applications, I don't want anybody peeking in. Through a transit gateway, just configure them not to share with each other and put them in different VPCs. The same stateful services, easy consumption from vCenter, but absolutely isolated from each other. It's mathematically impossible for packets to bleed into one another. And by the way, you put an edgeless management on top, that's about as lightweight as it becomes.